All right, today we're pulling back the curtain on a really impressive piece of high-performance engineering. It's an automation engine built from the ground up to solve a problem that plagues so many businesses: how to process massive amounts of data without hitting those all-too-common bottlenecks. We're going to see how it completely rethinks the approach. Let's dive in.
So, here's how we'll break it down. We'll start with the big data challenge pretty much everyone is facing. Then, we'll get into the weeds of this Orchestrator's architecture, look at the specific engineering choices that make it so fast, see how it gives you total visibility, and then tie all that tech back to what really matters, the impact on the business.
Okay, so let's talk about the big, invisible wall that almost every growing company eventually hits. You've got all this data, which is great, but actually getting anything useful out of it is slow, it's frustrating, and half the time you have no idea what's even happening inside that black box.
And this isn't just a tech problem. When it takes hours or even days to process data, your business is literally put on pause. Critical decisions get delayed, your expensive hardware and your talented people are just sitting there waiting. It's a massive drag on your ability to move fast and grow.
So, how do you fix that? Well, this system isn't just a slightly better script. It's a whole architecture, a blueprint designed from day one to demolish that bottleneck, using massive, and I mean massive, parallel processing. Let's look at the core logic here. It's actually quite elegant. Instead of trying to swallow a huge, slow job in one gulp, the system breaks it down. First, it slices that huge problem into thousands of tiny microtasks. Then, all those little tasks get dropped into a queue. From there, a whole army of worker processes jumps on that queue all at once. And as they finish, the results are collected and put back together safely. It's a classic divide-and-conquer strategy, just executed at a whole other level.
But how does it get that incredible speed? This is where we get into the really clever stuff, the specific high-level engineering decisions that make this thing fly.
So pillar number one is true multiprocessing. This code is built to see every single core in your CPU as its own independent worker, hitting the problem at the exact same time. It's all about squeezing every last drop of performance out of the hardware you already own. Nothing goes to waste.
The second pillar is like a secret weapon. It's called just-in-time compilation, or JIT, using a library called Numba. Now, what this does is pretty amazing. It takes the most demanding parts of the Python code and, right as it's running, translates them into super optimized machine code. So you get the speed and ease of developing in Python with the raw execution speed of a language like C. It really is the best of both worlds.
Now this right here is what separates a standard approach from a truly high-performance one. It's about how the different processes talk to each other. The common way is to use something like a manager.dict. It's fine, it works, but it's slow because there's a lot of overhead. This orchestrator instead uses low-level shared memory for things that update constantly, like performance counters. It's a direct, raw, and incredibly fast way to communicate. Let me put it this way. Using the standard method is like sending status updates via snail mail. This orchestrator's method is like having a dedicated direct hotline between the processes. The speed difference isn't just a little bit better, we're talking orders of magnitude faster. It's a complete game changer.
Okay, so speed is one thing. But what good is a fast car if you're driving it blindfolded? This is another area where the orchestrator is just brilliant. It takes that black box process and turns it into a completely transparent, real-time command center.
You also get this amazing level of detail through a live dashboard right in the console. And I'm not talking about a simple % complete bar. You get to see things like the overall processing speed, a constantly updated ETA, the average time for each tiny operation down to the nanosecond, and an exact count of tasks done versus tasks to go. It is literally mission control for your data.
And the best part, this isn't just for the tech team staring at a terminal. The whole thing is served up on a simple, clean web dashboard. That means anyone, a manager, a stakeholder, a client, can pull up a browser on their phone or laptop and see the exact status of a critical job in real time from anywhere. It makes observability accessible to everyone.
So, we've geeked out on the amazing technology, but now let's talk about the bottom line.
What does all this actually mean for a business? How does this kind of technical excellence actually give you an edge over your competition?
Well, the benefits are huge, and they are immediate. You're getting the maximum return on your hardware because you're actually using all of it. The system is designed to scale right out of the box. Most importantly, you are crushing the time it takes to make decisions. What used to take days now takes hours or maybe even minutes. Plus, with that total visibility, you kill the risk of a job failing silently. Put it all together and you have a processing power that most of your competitors can only dream of.
And why is that so critical? Because it's estimated that a staggering 95% of companies are still stuck using old, slow, batch processes where they have zero visibility. An architecture like this isn't just a small step forward, it's a massive leap ahead of the industry standard.
So as we bring this all together, it's really important to realize what we're looking at here. This is so much more than just a handy script. At the end of the day, a tool like this isn't just code. It is a physical demonstration of deep, hard-won expertise. It shows a complete command of multiple complex fields all at once: high-performance architecture, system observability, and hardcore systems engineering. This is what it looks like when theory is expertly put into practice to solve a very real, very expensive business problem.
So I'll just leave you with this one question to think about. Take a good, hard look at your own data operations, your own critical processes. Do they operate with this level of sophistication, with this kind of speed and this kind of control? Because as we've just seen, it's not a fantasy. It is 100% possible.